there, my name is Dr. Dorothy Buckley. It is my pleasure to welcome you to this video where we'll be talking about attention. So the first cognitive psychologist to really talk about the science of attention was William James. So this is a direct quote from or passage from James's Principles of Psychology, which was the first psychological textbook that he used when he taught his psychology course at Harvard. And it says, everyone knows what attention is. It is the taking possession by the mind in clear and vivid form, one out of what seems several simultaneously possible objects or trains of thought. Focalization, concentration of consciousness, are of its essence. It implies withdrawal from some things in order to deal effectively with others, and is a condition which has a real opposite in the confused, dazed, scatterbrained state. So really, that captures a lot of different facets of attention. However, some more contemporary psychologists that have studied attention more recently, most notably Hal Pechler, has said that this quote actually isn't reasonable at all and doesn't capture the nuances of what attention is, right? So it's more accurate to say, according to Pechler, no one knows what attention is, and there may not even be an it to begin with, to be known about, though of course there might be, right? So really what this illustrates is how complex of a process attention is and how multifaceted it is. So one of the significant challenges of studying attention is that there's not just one type of attention, but multiple types of attention. So whenever we think about attention, we can define three different types. So we have selective attention, which is the ability to perceive a particular stimulus while simultaneously ignoring other stimuli. So the classic scenario that would require you to utilize your selective attention would be if you were in a busy coffee shop, maybe studying for an exam, and you have your headphones in, you're listening to music, and you've got the loud, coffee or brewing machines in the background. You've got other people talking, right? So you've got to focus on your Spanish vocabulary or your calculus problems or whatever you might be looking at. You've got to focus your attention on those things while also filtering out the music and the conversations and the clatter kind of going on around you. So that's selective attention, is focusing your attention on a single stimulus while filtering out other stimuli that are less relevant. We also have divided attention. So divided attention is when two or more stimuli are attended to simultaneously and share cognitive resources, right? So this is, you utilize divided attention anytime that you are multitasking, right? So anytime that you text and drive, for example, or talk on the phone and drive, you are utilizing divided attention, right? Or maybe when you are texting someone and also having a spoken conversation with someone. And as you'll see with your thinking about cognition assignment, divided attention always means that because you only have one pool of resources to share between the different things that you're doing at the same time, right? Your performance on neither task is going to be optimal. Lastly, we have executive control / attention. So we talked a lot about executive control when we talked about working memory. Okay? So it's very much the same thing. So executive attention or control is a conflict detector, right? So it's an ability to suppress an inappropriate representation and activate an appropriate one, right? So the classic example of executive control or attention would be a scenario where you're washing dishes, right? So maybe you're at the sink, you're washing dishes kind of vigorously, making sure that you get the soap all around, right? And as you're washing dishes, your hand accidentally bumps a cactus off of a windowsill, right? So anytime you drop something that's fragile that you don't want to break, your kind of first thought or your typical response would be to reach out and grab that object to prevent it from being broken, right? But of course, if this is a cactus, right, if you were to grab it, you would actually injure your hand because of all the spikes, right? So in this case, your executive control or your attentional control would become activated to tell you to suppress your typical response of grabbing the cactus and instead let it fall. Right? So anytime we talk about executive control, there's a myriad of different scientific tasks we can use to study it, but the one that we've talked about the most is the Stroop task, right? So the Stroop task is when you are asked to name the color in which the word is printed, and sometimes the color is actually printed, or the word itself denotes one color, while the ink color is a different color, right? So the word red printed in blue. So anytime you see a word, right, your dominant response or typical response is to read the word, right? So your executive attention or your executive control allows you to stop yourself from reading the color denoted by the word, and instead engage your less typical response of reading the ink color. Okay. So to help us better understand how the cognitive process of attention works, as we often do, we're going to look at or we're going to examine neuropsychological disorders that affect attention. So the most common disorder that impacts attention are the attention deficit disorders. So most of the time when we talk about attention deficit disorders, we're referring to something called ADHD, right? So the DSM-5 gives us our criteria for diagnosing ADHD, and it also introduces us to different classes of symptoms. So attention deficit hyperactivity disorder includes symptoms of both inattention and hyperactivity. So biological males are more likely to experience most of their symptoms in the hyperactivity or impulsivity group, whereas biological females are more likely to experience inattention. So symptoms from inattention include things like lack of attention to detail or making careless mistakes, not seeming to listen, right? A child with ADHD in a classroom might give the teacher the impression that they're not listening. They might become easily distracted or forgetful. They might avoid sustained mental effort, right? So they might have difficulty carrying a task to completion, especially if it's a complex task with multiple steps involved. Um, they might have difficulty following through instructions or directions, or might easily get sidetracked. And then on the hyperactivity impulsivity side, we see what's called hyperexcitability, right? Or tending to fidget or move hands and feet or squirm in a seat if we're talking about a child, leaving the seat frequently, running about or experiencing restlessness, being excessively loud or characterized as always on the go, talking to excess, blurting out answers rather than raising one's hand, difficulty waiting one's turn, etc. So in order to meet the criteria for a diagnosis of ADHD, you must experience at least 5 symptoms per category in adults, and you must have experienced these symptoms for at least 6 months. The age of onset is typically 12 years, and both the inattention symptoms and the hyperactivity symptoms should persist in at least 2 settings, right? So if the child is not experiencing these symptoms in the home and only at school, they wouldn't meet the criteria for ADHD. For adults, if they're only experiencing this in the workplace and not at home, the same thing would be true. So we have to have noticeable symptoms in at least 2 settings, and there has to be a significant impact on social, academic, or occupational functioning. And it can't be accounted for by any other disorder, right? So, for example, it can't be accounted for other neurodevelopmental disorders like autism, for example. Okay. So now let's look at the different causes of attention deficit disorder. So first we can talk about environmental causes. And when we say environment in this case, we're referring to things that happen in utero or in the womb, or things that happen very shortly after birth. So if the fetus is exposed to drugs and alcohol in the womb, or if they're exposed to measles, for example, or rubella and other sort of toxic substances while in the womb, that can put you at risk for ADHD. Also, if you experience early childhood abuse, that can increase the likelihood of ADHD. We can also talk about, um, um, in addition to trauma and abuse and other environmental factors, we can also talk about what we call CNS insults, or that's damage to the central nervous system. So when we look at individuals who have had traumatic brain injuries, 30% of individuals with TBIs will go on to develop some form of attention deficit disorder. Attention deficit disorders also have they are heritable in 75% of cases. So 75% of cases appear to be of genetic origins. So you're 4 times more likely to develop ADHD if you have a sibling with ADHD. And finally, let's talk about differences in the brains of people with ADHD relative to people without ADHD. So if we look at neural structures, the most prominent difference that we'll see is that the prefrontal cortex is smaller, significantly smaller, and there's also significantly lower levels of norepinephrine and dopamine. Okay, but those lower levels of norepinephrine and dopamine could be something that naturally develops as a result of the disorder, or it could be a reflection of the fact that many people with ADHD are given stimulants to alleviate their symptoms, like Ritalin, for example. And as a result of long-term use of stimulants, your brain actually stops creating dopamine and norepinephrine as a compensatory response. So most physicians and psychologists believe that these reduced levels of neurochemicals or neurotransmitters like dopamine and norepinephrine reflect both adaptation to stimulants and sort of pre-existing neurochemical differences. One of the things that you guys saw in the Dr. Ramachandran documentary that you watched when we were talking about cognitive neuroscience is you were introduced to Peggy, who was an elderly woman who, as a result of a stroke, sustained damage to her right parietal lobe. And as a result of that lesion to her right parietal lobe, she was no longer able to attend to the left side of space, right? So Peggy would draw, when she was directed to draw a house or draw a clock, right? She would totally neglect the left side of space. Okay, so all of her daisies would include petals on the right side, but not on the left side. And similarly, all of the numbers on the clock would be kind of smushed over to the right side, but not the left. And even her faces were incomplete in the sense that the left side wasn't represented. And even if you were to put a plate of food in front of someone like Peggy with hemispatial or visual neglect, she would only eat the food on the left side because she was unable to notice or attend to the left side. So this is caused by, again, damage to the brain's radar system. So there's nothing wrong with Peggy's vision, okay? So there's nothing wrong with her visual cortex, or the area of the brain responsible for processing and recognizing visual stimuli. But rather, those visual stimuli don't activate Peggy's attentional system. So it's only when you make Peggy aware of the fact that she's been neglecting her left side that she then recognizes it temporarily. So this is another neuropsychological disorder that illustrates failures of the attentional system. So now we're going to focus on failures of attention that we all experience. So I asked you guys to watch 2 different videos from Simmons and Chabris, and one of the videos demonstrated something called inattentional blindness, and one of the videos illustrated, or a couple of the videos illustrated, what we call change blindness. So the classic demonstration of inattentional blindness was an experiment conducted by Simmons and Chabris in 1999. And in this experiment, they had participants made up of 2 different teams, or they had participants watch a video of 2 different teams of individuals throwing a basketball. So some people had on white t-shirts and other people had on black t-shirts. And the job of the participant was to count the number of passes between the players with white shirts and ignore the participants with black shirts. So this is a relatively easy task, but it does require you to engage your attentional system, right? So while the participants were counting the passes, a man dressed in a gorilla suit came in the middle of the in the middle of the screen and pounded his chest with his fists, right? So naturally, okay, this is a very easily perceptible or obvious event for those of us that aren't engaging our attentional system by counting the passes. But interestingly, over half of the participants failed to notice the gorilla, right? So inattentional blindness just means that you experience or you fail to notice, rather, an unexpected event when your attentional system is engaged by focusing on something else. And change blindness is a similar thing where participants watched a film of a conversation and they failed to notice, again, very, very obvious changes in the scene, right? So this was another experiment by Levin and Simons in 1997, where participants watched a video of a staged conversation, and many of the details of the video were changed, and people failed to detect the changes, right? So again, inattentional blindness is a failure to notice a very perceptible or very obvious unexpected event, like a gorilla showing up out of nowhere and beating its chest. And then change blindness is just an inability to detect changes in a scene. So the most extreme example of change blindness was a study also conducted by Simmons and Levin in 1998, and it's famously referred to as the door study. So in this experiment, a Confederate or an actor working with the researchers would ask directions from random people on the street. And when the Confederate or actor was asking for directions, two men who were also working with the researcher would walk in between the participant and the person asking for directions, and the person asking for directions would be switched to a completely new person. And so the question was, will that person notice the change? And overwhelmingly, most people failed to notice when they were busy giving directions that all of a sudden the person they were talking to was switched with a completely different person, right? And they failed to notice the change even when the new person was of a completely different biological sex, a completely different gender, a completely different age, a completely different height, a completely different race, right? So even very obvious, easily perceptible changes failed to be noticed by the participant. So this is a much less kind of interesting demonstration of inattentional blindness, but it was one of the first experiments to study this idea. And so if you were a participant in this experiment, you would be told to fixate your eyeballs on the center of the screen, and there would be a tiny plus sign, and that plus sign was known as a fixation target. And then with your eyes still focused on that little plus sign in the middle of the screen, you would see a long cross at another point in the screen, either the top left or the top right. And your task was to determine if one line is longer than the other, or if the lines of the cross are the same length. So again, the idea is that because participants are busy completing this visual task, right, that they're less likely to notice a change. So what the researchers found is that when the fixation target changed from a tiny plus sign to a diamond, and even if the diamond was colored in with like a neon yellow, people failed to notice the change. So in the original experiment, less than 10% of people failed to notice when the fixation target in the center of the screen changed from a plus sign to a diamond shape that was colored in a neon yellow, right? So that's a very perceptible, obvious change. And yet people were so busy trying to look at the length of the lines that they completely failed to notice. So the researchers were so stumped by this that they thought, okay, maybe it was actually hard to detect. But when participants were given a warning and told that the fixation cross would change, they would notice it over 90% of the time, right? So it seems that inattentional blindness and change blindness, again, isn't a failure of our perceptual system, right? So it's not our eyes playing tricks on us and failing to actually detect the change using our eyeballs, right, or our sensory perceptors, but rather it's that our attention is so engaged, it's so fixated, it's so engrossed in the task that we're doing that we don't have enough attentional resources, okay, in order to detect these changes. So again, what these results collectively illustrate is that multitasking really isn't a good idea, right? Because if we're trying to work on two things simultaneously, and one of those things takes up all of our attentional resources, okay, it's very likely that we're not going to be able to do the second task very well. So, what explanations have psychologists put forth to explain why these things happen? Well, Craig and Lockhart decided to examine multiple cases of change blindness, where people failed to notice or detect changes in scenes. And in thinking about this, Craig and Lockhart wondered if they could use a sort of levels of processing explanation, right? So, for example, thinking about superficial features often leads to significantly worse memory for information than thinking about meaning, right? So we know that from the study of memory. How can we apply that to to change blindness? Well, it turns out that at least for Western participants from countries like the United States and Europe, features of a scene are typically encoded at a very shallow level. So when it comes to visual processing of scenes, we tend to focus more on the central features rather than the features in the background, right? And we tend to use what's known as gist-based encoding, right? So if I were looking at this picture of a young college student, right, I would be more likely to focus on his face, okay, his facial expression, rather than trying to encode the background in detail. So I might say, oh, he was standing in front of some brown steps, but I certainly wouldn't remember, how many windows there were or how many steps there were, because I'm more likely to focus on the central figure in the photograph. Now, it turns out that people from Eastern collectivist cultures are much more likely to encode the visual features of the scene as well, but not Western or participants from Western cultures. And we'll talk about more. We'll talk about why that is at a later point in the course. But so I tend to focus on the figure in the photograph rather than the background scenes, right? So again, features of a scene are typically encoded at a very shallow level, and we don't tend to be very detail oriented. And successful change detection is going to require deeper encoding of specific features of a scene. And we also have a different way of thinking about a person that we're interacting with, depending on whether that person is a member of our in-group or a member of our out-group, right? So let's suppose that I am a college student, okay, talking to another college student, okay? Because that person is in my group or demographic, Okay, I am more likely to notice, okay, maybe the kind of backpack that person has. So maybe I got a North Face backpack for Christmas, and it's pink or it's purple and it has flowers on it. And the young girl I'm talking to has a green one with purple flowers on it. So I noticed that. Um, Maybe they're wearing the sneakers that I really liked that Taylor Swift was wearing in my favorite music video, right? Or maybe they have their hair styled in a way that somebody else I know has their hairstyle, right? So because I relate to this person, we're of the same age, right? We're of the same demographic. I am more likely to encode that person rather than encoding that person as a generic college student. Okay, I'm going to encode that person as Elise, the woman that I met on campus with the great sneakers and the backpack that's similar to mine, right? As opposed to if I was a college student and I met an older woman, okay, I would tend to encode her at a more gist based level. Like, okay, this is an older person, right? Um, so it's possible, okay, that this could explain some experiments related to change blindness. So what do I mean by that? Well, it turns out that when Simmons and colleagues did this experiment, they found that older people were more likely to experience change blindness relative to younger people, right? And that actually makes sense in the literature because with age, our capacity for various cognitive functions does decline. But another explanation is that if you're an older person and you're giving directions to a young college student, right, you're going to encode that person as being a generic college student rather than focusing on specific features. Whereas, like I said, if you're a college student talking to another college student, you're more likely to fixate on those specific details, right? So to test this explanation, they conducted an experiment where they had the person uh, who was asking for directions was dressed in a construction worker's uniform. Okay, so both young and old college students, when they look at somebody in a uniform, whether it's a construction uniform or a fighter uniform or a doctor's uniform, because of that uniform, you're going to be more likely to encode that person as a doctor or a firefighter or a construction worker, right? So putting the person in a uniform automatically kind of facilitates that category or generic level encoding instead of focusing on the details, right? And when they did that, when the person who was giving directions was a construction worker, um, both younger and older adults showed similar levels of change blindness. So there are a multitude of explanations, but that's just one way to explain it. Okay, so one of the last things that we're going to focus on is we're going to focus on explanations that cognitive psychologists have given to explain how selective attention works. So remember, selective attention is when we focus all of our attentional resources on one stimulus while simultaneously filtering out irrelevant information. So Donald Broadbent was a very early cognitive scientist in the 1950s and 60s. during the height of the information processing age, right? So this was during the cognitive revolution when people were interested in using computers as a metaphor for the mind. So Duff Broadbent was a very prominent scientist in Britain, and he spent a lot of time working with the British military in an area of cognitive psychology known as human factors. So, human factors is basically an early facet of cognitive psychology or an early subfield of cognitive psychology that attempted to decrease human error when humans are interacting with technology. So he was one of the people that attempted to change military aircraft in Britain to make crashes caused by human error less likely. And in fact, human factors is still a very prominent field today. And people who study human factors do very important work. But one of the specific populations that Broadbent worked with when he was consulting with the military was air traffic controllers, right? So air traffic controllers have been featured a lot in the media as of late because they have a very, very difficult job. Okay. And their job is basically to receive multiple signals from airplanes that are all simultaneously trying to either take off or land, or sometimes kind of detour from their scheduled route if there's bad weather or they encounter some kind of emergency. So air traffic controllers are kind of the single entity that coordinates with multiple pilots driving multiple aircraft to many different places. So basically, if you're an air traffic controller, you're receiving hundreds of simultaneous messages from various pilots in different aircraft, either asking if they can land, asking if they can take off, asking if they can divert and take another route. So it's a very, very stressful, very taxing work. And it requires one to be really, really good at selective attention, right? Because you have to prioritize the most urgent messages and simultaneously filter out the less urgent ones. So really what Broadbent wanted to do in searching for an explanation of selective attention is he wanted to model in the laboratory essentially what was the job of the air traffic controller. So to do this, Broadbent created a laboratory task known as the dichotic listening task. So dichotomy means two. So this task was referred to as the dichotic listening task because if you were a participant, you would put on a pair of headphones and you would receive two messages simultaneously, one coming in your right ear and one coming in your left ear. And just like the air traffic controller, you would be told to ignore one of the messages, right? So ignore the message coming in your left ear and only focus on the message in your right ear. And to make sure that participants were only focusing on the message in the right ear, Broadbent had them engage in a task known as shadowing, where they would repeat verbatim what they heard in their right ear. So it turns out that participants were remarkably good at attending to the message in the right ear, right? So people found this shadowing task very, very easy. They were very easily able to copy or repeat out loud the message that was coming in through the right ear while simultaneously ignoring everything in the left ear. Um, and they could, when they looked at the left ear or the ignored channel, as it was called, sometimes they tried to change things to see if participants could detect the change. So, for example, in the ignored ear or the left ear, they would change the speaker from a woman to a man. They would change the spoken language of the ignored message from French to Dutch. They would change the pitch from a very high-pitched voice to a very low-pitched voice. They would have random kind of racket or noises come in to the ignored channel or the left ear. And they found that people remarkably were unable to notice those changes in their left ear if they were focused on shadowing the message in the right ear. So again, typical results were participants were able to repeat 100% of the content from the attended channel or the message coming in the right ear, and they heard remarkably little from the unattended channel or the left ear. So they couldn't tell if they contained coherent messages or random words. They couldn't tell if it switched from German to French, and only 4 out of 30 participants noticed Czech passages being read to them with an English pronunciation in the ignored channel or the unattended channel. So if you've ever tried to read Czech passages with English pronunciation, it sounds very bizarre. Okay, so it would be very noticeable or it would be very obvious that something strange was happening. And yet people failed to notice it if their task was to shadow or repeat only what was coming in the right ear or the attended channel. So based on this early data, Broadbent decided to propose what he referred to as the early selection model. And you'll remember that the early selection model was an information processing model. So it used inputs and outputs and other features that were based on early diagrams of how computers functioned, right? So it's very similar in some ways to the modal model that was proposed by Atkinson and Schifrin. So basically what Broadbent said was going on is that we have input coming in from both the unattended channel or the left ear and the attended channel or the right ear. So that input is coming in through the headphones, okay? And the first stop is going to be the sensory register, okay? Which is essentially sensory memory. So everything that your ears pick up in both the unattended and the attended channel, or everything that registers through your ears in both the unattended and the attended channel, is temporarily stored in the sensory register. And then there is what Broadbent refers to as a selective filter. So based on physical characteristics, okay, you then filter out everything coming through the unattended channel, because remember, your task is to focus exclusively on the attended channel. So based on physical characteristics like tone, pitch, you filter out everything coming in the left ear and keep everything that's in the right ear, right? Or the attended channel. And then through the perceptual process, which is really just the meaning-based processor, okay? Um, so the meaning-based processor is going to focus not just on the physical characteristics or the sound of the words, but rather the meaning of the words, okay? Only the words in the attended channel are going to go from the selective filter to the perceptual process and be processed for meaning. Okay? And then we have short-term memory. So essentially, what the early selection model says is everything in the unattended and the attended channel is temporarily stored in the sensory register, which is basically sensory memory. So your brain has a very, very brief sound bite of everything coming in your left ear that you're supposed to ignore and everything coming in through your right ear, which you're supposed to shadow. And then the selective filter based on physical or sound-based properties is going to filter out everything in the unattended channel before it gets processed for meaning, right? So before it gets to that third box, the perceptual process box, okay, everything in the unattended channel is filtered out so that only information in the attended channel is processed for meaning. But right away, people started to notice a serious limitation of the early selection model. And that limitation is that not all of the information coming in the left ear or the unattended channel was actually ignored. Okay? So an experiment by Morey in 1959 demonstrated a phenomenon known as the cocktail party effect. So I want you to think, and if you were in a classroom with me, I would ask you this question directly. Have you ever been at maybe a family reunion or a really busy party or some kind of event with a lot of people, and you're deeply engrossed in a conversation with maybe a friend or a small group of friends, and all of a sudden, from all the way across the room, seemingly out of earshot, someone says your name. Okay? All of a sudden, your head kind of snaps up and you look in that direction, right? So that's something known as the cocktail party effect. So even when we're not paying attention, okay, or even when our attentional system is engaged in a completely different task, certain information, such as our name, is important enough that it immediately captures our attention. And so Morey in 1959 did the usual dichotic listening task with a participant who, by the name of, just for purposes of example, was named Bob. Okay? And so they had random words being presented in the attended channel and the unattended channel. Set, go, pan, Bob, right? And Bob's task is to shadow or repeat the words that he hears in the attended channel. So he's saying out loud, set, go. But in the ignored channel, in the left ear, the unattended channel, he hears random words along with his name. And 100% of participants, like Bob in this experiment, when asked if they noticed anything unusual in the unattended channel, they all successfully detect their name, right? So this illustrates what's known as the cocktail party effect. And basically, again, what it suggests is that even if we're successfully ignoring that unattended channel, if the information is self-relevant or important enough, it is going to capture our attention. So not all of the information in the unattended channel is being ignored, and at least some of it is getting processed for meaning. So what other evidence do we have that not all of the information in the unattended channel is being ignored, and at least some of it is being processed for meaning? Well, in this experiment by Mackay in 1973, in the attending ear, or the attending channel, participants heard ambiguous sentences, such as, "They were throwing stones at the bank." And in the unattended channel, participants heard a word meant to bias the meaning of bank. So they either heard river or money. And at test, participants had to choose which sentence was closest in meaning to the one that they heard in the attended message. And those who had heard the word river would choose the sentence, "They threw stones toward the side of the river yesterday." And those who heard money would choose, "They threw stones at the Savings and Loan Association yesterday." So what that means, even if the participant is successfully shadowing the message in the attended channel, at least some of the information in the unattended channel is being integrated into that message and therefore processed for meaning. Similarly, in another experiment by Gray and Wiedenburn, participants heard two messages. So in the unattended channel, they heard 9 April 6, or 9 Aunt 6. And in the attended channel, they heard Dear 7 Jane, right? And it turns out that the message that they shadowed was Dear Aunt Jane, right? So even though the participants understood the task very well, it seemed like they were attending to or noticing some of what was coming through the unattended channel, and they were integrating it with what they heard in the attended channel. Another experiment, participants were asked to shadow the message received in the left ear only. So in the left ear, they heard "sitting at the mahogany 3 possibilities." And in the right ear, they heard "let us look at these table with her head," right? So neither one of these sentences make sense. And yet what people reported was a very coherent sentence that included elements of both the left and right ear, and they shadowed "sitting at the mahogany table," right? So even when their task was to report what was coming through the attended channel, they kind of mashed both sentences together to create a sensical sentence, right? So it seems that not all of the information in the unattended channel is being ignored, and in many cases, stuff coming in through the unattended channel is being unintentionally integrated with stuff coming in through the attended channel. So what this means is it became important to update Broadbent's early selection model to reflect these data. So Deutsch and Deutsch decided to revise the early selection model, and they instead called it the late selection model. So the late selection model is exactly like the early selection model, except the selective filter comes after the perceptual process. So in other words, the information coming in the unattended channel and the information coming in the attended channel is processed for meaning. right? So everything, a snapshot of everything coming in the unattended channel and everything coming in the attended channel is registered temporarily in the sensory register. And then everything is processed for meaning via the perceptual process. And then after everything has been processed for meaning, then all of the information in the unattended channel is filtered out before it goes to short-term memory. So this model has the distinct advantage of being able to explain all of the experiments I just went through with you. But the primary limitation of the late selection model is that it violates a principle of cognitive science known as cognitive economy, right? So we've talked at length about how every human being has a limited processing capacity, right? So just like a personal computer, we all have a limit to the amount of information that we can process at one time effectively. And when it comes to paying attention and processing information with only a finite set of resources, right? It doesn't really make sense for us to invest in understanding the meaning of all of the information, especially since only some of that information is relevant to us. So the late selection model has the benefit of explaining all of the data that we just covered, right? But it has the significant disadvantage that if this is how our attentional system works, we would be using a lot of our processing power very ineffectively. So Anne Treisman decided to create what she referred to as the attention attenuation model of attention, or the leaky filter model, in an attempt to both explain phenomena like the cocktail party effect and some of the experiments that we just reviewed, but also to preserve cognitive economy. So in her theory, okay, she posited that something called an attenuator analyzes incoming messages in terms of their physical characteristics, language, and meaning. So the attenuator processes incoming messages in terms of their physical characteristics, language, and meaning. And the attended message is let through the attenuator at full strength, whereas the unattended message is let through the filter at a much weaker strength. So what does this mean exactly? Right? Well, to understand what this means, we have to understand what the dictionary unit is. So the dictionary unit contains words, each of which have thresholds for being activated by our attentional system, right? So words that are important, okay, or common, okay, are going to have very low thresholds. Whereas words that are less important or less common are going to have very high thresholds. Okay, so our own name is going to have a very low threshold, and common words like boat are going to have lower thresholds than less common words like rutabaga, for example, right? And so because the attenuator lets everything come in from the unattended channel at full strength, but the unattended channel brings things in at a much weaker strength, what that means is because of the dictionary unit, less activation is going to be required for important words like our name, or, for example, if somebody says Mercer, right? Or somebody says the name of your hometown, because you have common experience with those things, it's going to pique your attention, even if the signal itself is weaker because it's come through the attenuator, that's going to capture your attention, right? So the best model to explain the cocktail party effect, or the idea that you're able to detect your own name, even if it appears in the unattended channel, is the attention attenuation theory, or the leaky filter model, okay? Which is basically trying to explain both the limitations of the early selection model, most notably the cocktail party effect, and also reconcile all of the evidence against the early selection model. All right, so this concludes our lecture on attention. Thank you so much for joining me today, and I hope you have a wonderful day, and I look forward to chatting with you in my next video.